Well, in order to tell you where biological science are today, we have to start in the 18th century, when the influence of the philosopher Kant allowed the extraordinary progress that there was throughout one century on the understanding of embryology. So at that time, the researchers that followed Kant understood that an organism is the cause and consequence of itself. So that is a loop. And that is one thing. And the other important thing is that they understood that organisms are agents. They can generate action, movement. They can even generate their own rules. And that distinguished them from non-living matter. Then, at the turn of the 19th century into the 20th, with the acceptance of the theory of evolution, some biologists started to think that removing agency from the organism, in other words, the organism became a passive thing, and putting agency on natural selection allowed them to do the science they wanted to do. So that it was the first serious problem with science in the 20th century, biological science, this misplacement of agency. Then it came the mathematical theory of information that brought, as a practical consequence, the computer. The use of the mathematical theories of information in biology came like a transplantation. Takes this from mathematics and without any critical discussion, transported to biology. And that produced deleterious effects because organisms, we are not programs, and DNA doesn't have information. And adoption of a theory wasn't really adopting the mathematical theory, but it's the metaphoric use of the terms created by the mathematical theory. That produced part of the problems that we have now. The other important thing is that because information usually is conceived as digital information that is discrete, it pushes causes to discrete components as well, like molecules. And that was what gave impetus to the molecular biology revolution. After that, what people are looking for all the time is causal relationships with molecules and genes. And that also is not very useful to understand biology or biological specificity, because the specificity of what a cell does in the organism is not due to the molecules inside the cell, is due to the way in which this cell moves in time and space. In other words, differentiation is a consequence of where the cell was throughout its life, and that is what determines its biological specificity. So we think that at this point what we have to do is take a critical look on all these presuppositions that haven't been analyzed, yes, by philosophers, not by biologists, and instead of saying, okay, the theory is good, or the way we think is good, life is too complicated, and do more and more of the same, this time with an immense amount of data, we should stop and say, are the principles that we are using the correct ones? To me, the answer is no. That is why we stop and started to rethink the problem and try to find appropriate principles to study biological complexity.